How's it going, everybody? Today we're going to talk about the limit of a function. In this, we'll begin for our class in chapter 2.2. So first off, we're going to start by investigating the behavior of a particular function. And this function is written as f of x equals x squared minus x plus 2 for values of x near 2. So notice we are evaluating this function specifically for values of x near 2, which is bringing us into a greater understanding of what we mean by the limit. Now, as we are evaluating values of x approaching 2, we notice what happens to our values of f of x. And that's something we want to pay very, very close attention to here. As the values of x increase and gradually get closer and closer to 2, 1.99 is just below that value of 2, okay, we notice that our values of f of x, okay, right here, are also approaching another value. And if you take a look at this, if the values of x are approaching 2, what do we think the values of f of x are approaching? If 1.999 is very, very close to 2 and essentially approaching 2, then I would say 3.997001 is approaching 4. And now if we take a look at the other side, so here we're kind of approaching it from the left, you might say, from the negative side, all right, from negative infinity. If we're approaching from positive infinity here, we notice our values of x are getting smaller and smaller and smaller and smaller as they get closer and closer to 2, but don't ever actually equal it. And if we look at our values of f of x, they're getting smaller and smaller and smaller, and instead approaching 4. So notice as we approach from the negative side, we are also approaching from the positive side, all right? As x gets closer to 2 from both sides, f of x is also getting closer to 4. Okay. Now, we can see graphically how that works here, but as we approach from the right side, we're getting closer and closer to 2 for values of x, but closer and closer to 4 for values of y, or f of x. And as we approach from the left side here, closer and closer to 2 for x, but closer and closer to 4 for our values of f of x. Okay. So the way that we express this is we say that the limit of the function f of x equals x squared minus x plus 2 as x approaches 2 is equal to 4. And the notation that we use is right here. Okay. Now our next slide takes a look at a specific definition of the limit. And this is one of those places where I would probably take a screenshot, throw it in a Google Doc or a Word document to prepare for the final exam. But basically, right here, they're teaching us the appropriate language that we use when we read this. So if we look at this symbol right here, we write this, but what we say is the limit of f of x as x approaches a equals L. Okay? If we can make the values of f of x arbitrarily close to L, so we're getting so close to L as we'd like by taking x to be sufficiently close to A on either side of A, but not equal to A. And this not equal part is very, very important because often we might get caught up with saying, well, wait a second, if it's equal to it, maybe that can't happen. Maybe it's undefined, and that's how sometimes we can get tricked in these different types of problems. Okay, so in alternative notation here, this is just another way of writing it, and I'm going to go back here, okay? But we have an alternative notation here. We can say f of x approaches L as x approaches A. Just a different way of writing it, okay? So now these are just a couple of different graphs that are showing us what happens, right, as we are approaching A, what our value of L is. So again, A and L in many ways are values that, well, A is typically given, right, and L is something we are trying to find. So we know what X is, and we're looking for L. So this is another example here, and this goes right back to what I was talking about with you got to be careful with setting Here it says that x is approaching 1. So in this particular case, I mean, something should jump out at us right away. We have a denominator here, and we have to be very careful when we have a variable in the denominator, because if there is a value of that variable that makes the denominator equal to 0, then we can say that this is in fact undefined. So we have to be careful here, and when we look at this and we think about x approaching 1, if we were to plug 1 in here, the numerator would equal 0, but the denominator would also equal 0, which would tell us that this would be undefined. But remember what we said, it's not x equaling 1, it's approaching 1. So it's getting infinitely closer and closer to 1, but never actually equaling it, okay? And that's what we're talking about, the limit as x approaches 1. Right? That's the key piece here. So if we take a look at it, we'll notice that as we approach from values that are less than 1, we're getting closer and closer to 1, but now our value of the function, or f of x, is actually getting closer and closer to 0.5, right? And that's the same thing as we approach from this side here. We're getting closer and closer to 1 from the right side for values that are greater than 1, and we are continuing to approach 1/2 or 0.5. So we can say, on the basis of the values in the table, we can make the guess that the limit as x approaches 1 of x minus 1 divided by x squared minus 1 equals 1/2 or 0.5. Okay. Now, I also want to take a look at this function here. So it's in example 1, it's illustrated by the graph of f. So this was the graph we just looked at. But now if we're changing it slightly and we're taking a look at g of x equaling 2, the deal is, so we can say that x does not equal 1 in this case, but in this case we could say if x equals 1. Okay? This new function g still has the same limit since x approaches 1. So even though we're talking about 2 here, it still has the same limit because x is approaching 1. Now we're going to talk about one-sided limits. So one-sided limits, and when we talk about a side, it's how we're approaching that value of x, how we're approaching it. Are we approaching it from a negative side, from negative infinity, or are we approaching it from positive infinity? Okay? We take a look at the function h of t. H of t equals 0 if t is less than 0. But h of t equals 1 if t is greater than or equal to 0. So you notice here we have two different limits. This is a one-sided limit. Typically, all right, in most cases, we would have, from either side of the function, we would be approaching the same value, all right? The limit would in fact be the same. But here in this case, the limit of the function h of t as t approaches 0 from the negative direction equals 0. However, the limit of h of t as 0 approaches from the positive direction is 1. Okay. Now, the way that we read this is very important, but we write this and we say that the left-handed limit of f of x as x approaches a, or the limit of f of x as x approaches a from the left, is equal to L if we can make the values of f of x arbitrarily close to L by taking x to be sufficiently close to a and x less than a. Notice that definition 2 differs a little bit from definition 1, only that we require x to be less than a. In this case, we're requiring x to be less than a because we're approaching from the left. We're approaching from the left here, okay? If we're approaching from the right, then we would be requiring x to be greater than a because we're approaching from positive infinity, okay? So similarly, if we require that x be greater than a, right, just like I said, all right, I'm repeating myself here, but that, if it's greater than a, then we can say it's from the positive side, right? Okay. So this is, the comparing the definitions, but we can say that the following is true, that the limit of f of x equals the limit of x as the limit as x approaches a of f of x equals L if and only if we approach from both directions and the limit equals the same thing, okay? So we're not talking about one-sided limits here. We are saying that the limit is true, that this falls true if and only if we approach from negative values and we in fact equal the limit, and we approach from positive values. We approach from negative infinity, we approach from positive infinity. Okay. We just have a couple examples here to help us to better understand that. So, the limit as x approaches 2 from the negative side, so we're approaching 2 from the negative side, we're approaching 2 from the positive side, right? We're approaching 5, we're approaching 5. So basically, use to state the values if they exist, all right? So does the one limit exist? So from here, as we're approaching, this would in fact be a one-sided limit, because as we're approaching 2, we're getting different values of f of x. Here, as we're approaching from the negative side, right, this is going to equal L equals 3, but here L equals 1, okay? I'm sorry, over here for B, L equals 1. Now if we took a look at the limit of g of x as x approaches 2, okay? As it approaches 2, we have two values, two differing values here. But notice if we take a look at 5, as we're approaching 5, we have the same values here, the same values. From the graph, we see that the values of g of x approach 3 as x approaches 2 from the left, but they approach 1 as x approaches 2 from the right, okay? Therefore, right, we can say that A equals 3, we can say that B equals 1, noticing that they're different things. In C, since the left and the right limits are different, we can conclude that the limit as x approaches 2 of g of x does not exist. So there is no limit, because as you approach from both angles, it doesn't exist, okay? However, for this one here, we can say, all right, because it equals the same thing as we approach from negative values, as we approach from positive values, or values that are less than 5 or greater than 5, rather. This time the left and the right limits are the same, and so by 3 we have the limit as x approaches 5 of g of x does in fact equal 2. Despite the fact, notice, that g of 5 does not equal 2, okay? And that's that point that we saw up here in the previous screen, okay? Right here. Okay. So that is our conversation on limits. And we're going to move to, in our next video, we're going to talk about calculating limits using limit laws.